Hello, London. My name is Lea. I'm a software engineer, and for the last 5 years, I have been working at FundApps, a RegTech company based in London. What I'm going to share with you today is a real story. The challenge we in FundApps, at the time startup, faced when we started signing more clients, when we started attracting bigger names. How we re-architected our platform to be able to support that, and how we made it cheaper, faster, and greener along the way. So maybe some of you will find this familiar. I actually expect a lot of nods from you. Maybe you're at a different stage. Maybe where you are where we were. Maybe you took a different path. Maybe you ended up somewhere completely different. Or, maybe you don't find it familiar, but you will then potentially learn something and finding interesting. What I really want to finally leave with you is a sense of urgency. And most specifically with the last part, with the greener part. So if you do stick till the end, I'll be very happy. But now is the time, if you realize you're in the wrong talk, to go to a different talk, because in my opinion, NDC talks, the most benefit you get is from the conversations triggered by the talks you went to. From talking to speakers, from talking to people. And you can always rewatch these talks later on. If you do stick till the end, please come and chat to me. Questions, opinions, suggestions, ideas, how to make it better. I did work on this project for a long time, for 2 years. And I'm very passionate about it. But it doesn't mean that we did everything right and that we considered everything. Please come and talk to me. NDC London is actually the first NDC conference I've been to 2 years ago. So it's happy to be home. And actually how I got on this stage by talking to people and to the other speakers. So as I mentioned, today I'm going to share with you the journey we in FundApps took to build a more sustainable future for our business, but also for the environment as a B Corp. Show of hands, how many of you know what B Corp is? Okay, couple of hands. The official thing that I got from their website is there. Certified B Corp corporations are companies verified by B Lab to meet high standards of social, environmental performance, transparency, and accountability. What that means, in plain words, it's a standard, it's a way for companies to prove that they're not there just for the profit, that they're actually making something that is not that bad for the environment, that they're thinking about the community, that they are there to do something worthwhile. So we started with the monolith, with a single process application running on a self-hosted architecture, and we re-architected it to be distributed, cloud-native application in AWS. We were on this journey for 4 years, and today I'm going to share with you what were those challenges, why we need to go on this journey, how we faced them, and what came out of it. But before I'm able to do that, I think you need to know, it's useful to know who we are and what we do, to use that to frame your thinking. FundApps provides compliance as a service to the investment management industry. Our main product is shareholding disclosure. What that means is that the investment companies like banks, hedge funds, pension funds, when they cross a certain threshold of owning an investment, so when they own a share in a company, they need to disclose it, hence why shareholding disclosure. So simplified even more, let's say I buy some Amazon shares, and somehow I ended up owning 5% of all of the Amazon shares in the world. First of all, I probably wouldn't be here. I would be sipping pina coladas somewhere on a beach. But then, when I stop daydreaming and I come back to the real world, owning such a massive chunk of a company like Amazon doesn't come without worries, I can't just keep it a secret and silently pile my share of Amazon shares. I actually need to disclose it to the world through the regulators. I need to say, hey, I own 5% of Amazon shares. It's not just a courtesy call, it's the law. If you don't do it, there are a lot of fines. So you could be fined. It could damage your company's reputation. And in some countries, you could even end up in jail. Keeping an eye on these changes in the regulations that could be even daily, it's really hard work. And it's not just the regulation that changes. It's also certain conditions that could change. So let's say today I buy some shares. I don't need to do anything. If that company is tomorrow being acquired by another company, the rules change completely. So you have not done anything. You have not bought or you have not sold any shares, but now all of a sudden you need to do something. And that performs a challenge, right? All of a sudden you need to monitor all of that. And instead of all of our clients having a team of regulators and team of developers that keep an eye on these changes in the regulation and changes in these conditions, why not do it just once? Another thing that is important is the deadlines. Because if you had all of the time in the world, like, who cares? You could do it eventually. But these deadlines are sometimes even on the same day, which means that you really need to be fast and you really need to keep monitoring with everything that is different. And it actually might be different in different jurisdictions. So the solution for all of these clients is actually the same, but just the data that they're providing is different. And as software engineers, we know the power of third-party tools, right? It reduces the maintenance burden. It saves some money. It saves some time. It's also the power of community and support. And FundApps provides exactly that to the investment industry, to these companies, a way to automate monitoring of these changes and let our clients know when they need to disclose. We monitor over 17% of global assets under manager for shareholding disclosure for 130 of our clients. That's just under 19 trillion US dollars. We were founded in 2010. And what's important for today's story is also that we have been bootstrapped. That means we didn't have any injections of money, which means we have also been very lean and tactical, especially at the beginnings. And use that to frame the thinking with the next slides. So our mission is to make compliance simple through community and automation. Let's look at the client's workflow. Imagine there is a hedge fund based in London. Let's call them Enigma Capital. On a daily basis, they will provide a snapshot of their end-of-day positions in the form of XML, and they will provide it either through UI or through the API. At the heart of what we do is the rule engine. It's a highly bespoke, highly complex, and we use it to model the regulation. So the rule engine will take the client's positions, it will run analysis over them, and it will provide some results. We get the regulatory information from a law firm, and then our in-house team of regulatory experts will take that information, it will transform it into rules, which are then shared across all of FundApps' clients. For our clients, when they get these results, they'll continue with their daily workflows. So they might review those results, they might generate some documents to send to the regulators because potentially they need to disclose, or potentially they need to fix some data issues on their side and then rerun the files. In order to better explain what challenges we had, let's dive deeper into what does this rule engine do. So I mentioned the XML file from Enigma Capital, so let's build that XML file. Every position will have a set of properties attached. ID, price, currency, total shares outstanding, quantity. This quantity is how many Amazon shares I would need to buy to own 5%. It's a big number. If you multiply it by the price, yeah, I'm rich. Or I would be rich if I had that. Every one of these positions will then be subdivided into groups. We call them portfolios. Portfolios represent our clients' internal structure. They represent a legal entity on our client's side. So portfolio can be me, the Lea Trust, because why not? Because I own 5% of Amazon. Or it could be an investment manager, Amber, on our client side that is responsible for a set of investments, and their clients could be potentially you. The rule engine will take those positions, it will take that file, it will validate them, it will then enrich them from all of these different sources. So let's say we calculate the price in euros, we take some exchange rates from a third-party tool, from a third-party API, we add this to our client's positions because we will need it in the later step. Then the rule engine will take those enriched positions and it will run a set of regulatory rules over every one of each of these portfolios. So that means it will run a set of rules over my portfolio and over Amber's portfolio. These steps validate the positions, plan, calculate the properties, calculate the rules on each of the portfolios, and store the results to the storage. They need to happen in sequence. But the individual calculations within these steps, let's say calculating a single rule on Amber's portfolio, those can happen in parallel. It's unlikely, impossible, that our clients will have only 3 positions in their file. So let me give you some sense of the numbers. Our clients will have over tens of millions positions, and each one of those positions will have over hundreds of properties attached to it. Every one of those positions, again, is subdivided into groups, into portfolios. And due to complex internal structures, our clients could have over 50,000 portfolios. The rule engine will then run rules over those groups over those portfolios. We cover 100 jurisdictions, and we have over 500 rules. If we combine that, we get to 20 million individual calculations. And I'm not talking here about adding 2 numbers. We're talking here about rule evaluations, which might be happening over millions of positions. That's a huge number. But what's also important is the time frame. As we said, the deadlines for disclosing are potentially on the same day, which means that our clients need these results immediately, as soon as they send their position files. They might need to fix some data on their side, which means they might need to rerun. So it doesn't leave us, or it doesn't leave them, much wiggle room. For our clients, nowadays, it's usually 5 to 15 minutes for file runtimes. But for some of our complex clients, we have committed to 60 minutes, which has been a challenge at some point. To go a little bit deeper, why that was a challenge, let's go into this. When FundApps was started, the rule engine was, of course, developed or implemented with technology available in 2010. What will not come as a surprise, but that was a monolith. How many of you are still working with monoliths? Okay, so you might feel some pain. So we had a small farm of large Windows boxes that were doing the work, that were running the rule engine. Our storage was SQL Server. Again, self-hosted on another set of very chunky Windows boxes. Our clients send us files on a daily basis, but they send us when the markets are open during the week. And since it's a snapshot of their data, of their end-of-day positions, they usually just do it once a day. That means that these big boxes, large and powerful, most of the day they're just sitting and idling. They're absolutely not doing anything. We found ourselves with this around utilization of like 20%, which is horribly underutilized. But we needed to have them always on and over-provisioned so we can support the load. Because we couldn't impact our clients' runtimes, it wouldn't be good, right? So a lot of money was wasted on this, on these heavily over-provisioned, underutilized infrastructure that was always on. And then, of course, I can't really say that we could support every load, even with these big boxes, and even with the biggest Amazon box at the time, which was 1 terabyte. For this one client, it took 16 hours to process their file. It was bloody expensive. There was zero profit in actually having that 1 terabyte box just for that one client. And they were not getting value. What value do you get after 16 hours of running a file which could potentially fail? And then, what if you need to rerun to fix some data issues? We lost that client. Additionally, the rule engine was generating a lot of data. And we started having some backup issues. Amount of data stored in the SQL database started to cause a lot of problems. Due to the nature of our client's business, we need to have replicas, we need to have backups. At days, we would be generating 300 gigabytes of data daily, and at that time, the primary instances across all of our clients were around 100 terabytes. With replicas and backups, that's 400 terabytes. And then additionally, with all of this always-on self-hosted infrastructure, patch management, weekend work, drifting configuration, we basically had a maintenance nightmare. To utilize these underutilized boxes, right from the start, we shared them between multiple clients. We did save some money, we did save some energy, we did make it better for the environment that way. But that didn't come without no consequences. Our clients started feeling noisy neighboring impacts, clients impacting each other. And with time, as we were signing more clients, and as we were attracting bigger names, we were also attracting bigger load, bigger data sets, which meant our clients were experiencing these negative side effects and noisy neighboring effects more often. That meant longer runtimes, unpredictable runtimes, and even file failures without getting any results. And the computational power was not the only thing they shared. They also shared this expensive and powerful SQL cluster. In turn, it was taking us a lot of time firefighting, trying to optimize this engine that really, there was no point of optimizing because it has its own limitations. It didn't have its own future. It wasn't sustainable. So with these challenges, with this infrastructure, it would be very expensive to support any larger clients and more clients bringing on board. And it actually made us worried that we would not be able to support them, like we couldn't support that one client, which would be commercially dangerous. And it made the engine become a very serious business growth and sales barrier. This was us in our old office in Shoreditch, if you're from London, diagonal from here. Yeah, basically exactly like this, pre-pandemic. So let me paint a picture. It's Monday morning, you got to work, it's 10 a.m., you just finished your stand-up, you're starting the week, you have your coffee next to you, you have opened your Rider, Visual Studio, whatever you use. And my phone starts to ring, and it's pager duty alert, pager duty alert. I was like, oh God, what's now? And then my colleague's phone starts to ring, pager duty alert, pager duty alert. And you kind of like, in a row, you kind of have a couple of people, and it's like, this is not good, check the Slack, and it's all flooded with the error messages. We start an incident workflow, and of course, like, we immediately suspect that we are not going to be able to do much, but okay, let's try to figure out what's going on. Of course, it's something like, you know, this client that we just signed is a little bit bigger than we expected. Or we had put one too many client on the same box because they're shared. Or it's 10 a.m. in the morning, we have started the backups on Saturday and they have not yet finished, which means the database is burning and everything is on fire as clients are also putting load on it. It's a nightmare. And usually the solution for all of this is to throw more money at it, which meant give it more CPU, give it more memory, give it more power, because anything else that we wanted to do would just take a lot of time, a lot of engineering time to do any meaningful changes. I hope this paints the picture. Like, our cost of maintenance became too big, like larger than any business would like. And we need to do something. So we made a big and scary decision back in 2019 to rebuild the engine from the ground up. In order to be there for our clients long term, we needed to make this massive investment, both in terms of money and time. And you know what? Like, maybe not a lot of companies would have done it. But one of our values is have courage. So we went for it. This is what we came up with. Cloud native and share nothing. We were already big on AWS, and we decided to use as many managed services as we can. That meant we can focus on solving our business challenges, solving our client challenges, instead of the technical ones. AWS is amazing at that. They can scale up the services, they can do the patch management, they can manage database backups. All of that undifferentiated work, well, that doesn't matter, like, in which industry you're on. Like fintech, hospitality, health, it really doesn't matter. Database is a database. Scaling up a service is scaling up a server. So we let them do the heavy work for us. Of course, we paid. We wanted to enable work at extreme scale. We wanted to improve our security. We wanted to increase the visibility and simplify our operations. And we did. Firstly, by designing our systems to be able to horizontally scale the compute. Secondly, by using different data persistence solutions that fit the data better, that fit the problem it was trying to solve. By that point, all of the data that we had was in this monolithic relational database, the SQL server, and then shared, so SQL cluster. And one of the biggest problems is just a couple of columns in that database did not fit there. And yet they were responsible for the biggest chunk of data that was stored at. If you were at the keynote, this might sound familiar from Leila's talk. Those were JSON blobs, big JSON blobs, big JSON blobs of compressed data. What do you do with them in the relational database? Third, we made sure we are not sharing infrastructure between our systems components, but also between the clients, of course, where that made business and technical sense. So with these benefits, design principles, let me give you one more example, a simple one that made a lot of difference for us. When it comes to security, our principle is the one of least privilege. With all of this data being in the same monolithic shared database, that meant when there is an issue, I can't access any of that data. There is a small group of people that can. They become a bottleneck. They also become a risk, because when they go and access one client's data, they're basically accessing all of the client's data. Let's say you select the wrong database. So to resolve that, first of all, we made sure that clients are not sharing the storage and that our demo data is not in the same databases. That meant we reduced the risk. It also means that I can access some of the demo data if I need to. And second, we made sure that we use different storage solutions. That means that we can segregate the data better, and we can take advantage of different permission levels. So if there is a problem the client is experiencing, I can access non-confidential data, I can identify the issue faster, I can potentially identify the improvement if there was no issues at the moment. So what I'm going to share with you today is 3 patterns that got us to feel these benefits. 3 patterns that use these design principles. And each one of these patterns got us a step closer to migrating 130 clients to the new architecture. Clients of different shapes, clients of different sizes, with all of the feature that the old architecture, the old platform was supporting. This was a project that took us 4 years. It finished last summer. And as one of my colleagues said, it was sort of like changing a tire on a racing car that is still moving. It was thrilling. I think it's not an opportunity that happens often. And it was really amazing to be part of the success story. Before we go into introducing these patterns, and the first one being distributing the compute, I think it's important or easier if we introduce some of the main blocks. How many of you use AWS or have used before and privately, at work, read something about it? Cool. We use step functions. We use them to orchestrate the work. So it's sort of like workflows, and they connect the pieces together. SQS, simple queuing system, is for distributing the work. We find the small units of work, we send the messages, we fan out. S3, Amazon's serverless file storage. A perfect place for those JSON blobs, huh? We use it in 2 ways. One is temporary storage between the steps that the system is going to be doing, as now it's distributed. And the second one is a long-term storage. DynamoDB, again, used in 2 different ways. It's a document store, serverless from Amazon. One way is to point to those temporary or long-term files in S3, so kind of metadata. And we also use it to track the work. As the work is distributed, we somehow need to keep track of all of the pieces, moving pieces that are happening. Lambdas, simple compute, small operations. Simple example for that, at the time where we were introducing step functions, we need them to kind of wait in a loop and wait. Step functions didn't know how to add 2 numbers. So one of our lambdas is adding 2 numbers. Very sophisticated, but it's useful. Those of you who know step functions, you know that they now do that, but that's beside the point. Fargate container and ECS. So Fargate is sort of like a serverless Docker container. Fargate containers are going to be our mini engines, rule engines. They're going to be doing all of the calculations, doing all of the work. And since we need to spin up a fleet of these Fargate containers, we use ECS to do that, or ECS does that for us. At the moment, we spin up 50 to 300 containers and then do all of that work. And the last one is Aurora Serverless V2. It's a relational database. What's interesting about it is that it can scale up on demand really fast, and it can then scale down. Cool. We use it for the long-term storage. Now, when we know the main building blocks, let's put them together to introduce the main pattern for compute. Let me just check the time. Okay. The rule engine uses step functions, and the first step to orchestrate the work, and the first step is to partition the work. The output of that step is then stored in the temporary storage. This is where the engine will take that big piece of work that needs to be done, split it into smaller parts, and then from that, after it's stored in that storage, it's going to be used in the next step, where we take each one of those jobs and send them each as a single SQS message to be processed. As well, with that, we will store it into Dynamo to track the work. The step functions will then be running in a loop, checking that Dynamo. Is it done? Has it been done with all of the pieces of the work? When it's done, it goes to that one of those next sequential steps. But something needs to process those messages, right? So that's the ECS, the Fargate containers, the mini rule engines. They're going to be taking each one of them a message per message, and they're going to be processing it, storing the output in the temporary storage, both in Dynamo and S3. There's also going to be some in long-term storage, but more about that later on. And yeah, they're going to be just going chuckling through those messages. At the moment, we spin up 50 to 300 containers for each one of our clients. The number of those containers really depend on the size of the shape of our clients. So those clients that have more portfolios will benefit from a larger number of these instances. As you remember, the portfolio and running a single rule on it is the smallest unit at the moment, which means more portfolio, more smaller units to do, right? And at the moment, well, actually, those containers are running in each client's AWS account. So that means we resolve the problem of noisy neighboring. And if all of our clients send us files at the same time, we could be running 80,000 Fargate containers at the same time comfortably. We're using just a fraction of AWS's soft limit. I think it's 1,000 containers at the moment, which means in future, we could be running 2,000, 3,000 containers for each client. And the size matters, the size of these containers. Since the portfolio is the smallest unit, those clients that have big portfolios that could be millions of positions will benefit, well, they will not be able to run, but they need larger containers. At the moment, the biggest containers that we have are around 60 gigabytes. So imagine 60 gigabyte containers, 300 of them processing these messages. So what problems did we solve with this? What challenges? We don't no longer have bottlenecks on memory and CPU when it comes to computation because we have distributed the work. We no longer have noisy neighboring issues between the clients because each one of these computations for clients is happening in their own AWS account. And because now we are spinning up these Fargate containers when the engine starts and then spinning them down when it's done, we don't have those underutilized Windows boxes that are just sitting around and idling. So we also save money and energy there. So we solved the computational problems, but we still have storage problems. As you remember, the storage is also shared. And we had two problems with the storage, well, at least. The first one was bottlenecks on CPU at the peak time of usage. So when the engine is doing the work, it needs to store the data into the database, and potentially that's a huge amount of data at the same time, potentially from multiple clients because the storage is shared. Another problem that we have, challenge, engine generates a lot of data and stores it to a storage. So our storage started growing rapidly, and because of those replicas and backups started to cause a lot of problems. In this instance, the problem, the data that was causing all of this was actually not the result data that the engine was generating. It was actually enriched position data that we generated during the file run. So remember those positions in XML? When we enrich them with additional data and potentially tens of millions with hundreds of properties attached to it? That was stored in a SQL Server, as you remember. Those JSON blobs, compressed JSON blobs. For one of our clients, their primary instance of database was 21 terabytes. And this compressed JSON data of enriched positions was 19 terabytes of it. That's over 90% of data that doesn't even fit into the SQL database. It doesn't take advantage of any of the characteristics of the SQL Server. And we need to get this data outside there. So the solution, the tool for the job here, was S3. It's a cheap storage. It fits very nicely with JSON data. It doesn't have a lot of querying capabilities, but we didn't have any with SQL Server. But combined with S3 Select, we got just enough. So we could query the data. We could pull in the subset of data that we needed, subset of those properties. And it did the trick. The problems that we resolved was basically lowering the maintenance cost because we reduced the amount of data stored in SQL Server, which means backups were no longer causing an issue. Because we were not storing it into the database, there were no bottlenecks on a CPU. We were not putting pressure on the SQL database. So we also removed the noisy neighboring. Great, right? I think it's time for pause for a little bit. We introduced two patterns, and I spoke a lot about this. And classic engineer's mistake, talking about a lot of tech and AWS buzzwords. But what's the most important thing? Why are we doing this? Does it work? Did it bring any value to our clients? Did it have any impact? Yeah, it did. For some of our more complex clients, it made a significant difference. Let me give you an example. This is an email that we got a day after the migration from our client, the largest Canadian bank. It says, "Hi, today's XML file uploading process completed in 39 minutes. It usually takes around 1 hour and 40 minutes to complete. Could you please confirm that everything is fine?" How would you react if we got this? I would start panicking, have we dropped half of the positions? Have we not processed some of the rules? No. I think we're pretty pleased with what we have done. Imagine bringing back 1 hour of time to our clients, 1 hour of time that they can potentially spend bringing back the value to their clients, which could be you. So with these two patterns, the distributing the compute and removing the biggest part of the data that didn't fit in the SQL outside it, we could migrate 90% of the clients to the new architecture. And we did. We migrated those 90%. But 90% is not 100%, right? And we still had those 10% to migrate, which we couldn't because they were just too slow on the new infrastructure. This is the same diagram. The problem again, the bottleneck, was a SQL cluster. This time, for some different reason. So we need to rewind a little back. The engine generates a lot of data, a lot of results. It needs to store them at the same time really fast. Now when we have distributed the compute, that is happening a lot faster, potentially from 300 containers. Have you ever tried writing 20 million rows from 300 containers to SQL cluster? We have crashed it. Don't get me wrong, we could have given it more power, but that would be so expensive. It would be so not worth it. So we need to do something. For these 90% of clients, we came up with a workaround so we can migrate them. So workaround was, instead of writing to SQL from all of these containers, we store the data to those results to S3. And then later on, when that's done, we slow feed them to SQL cluster from a single container. And for these 10% of clients, that was just taking too long. That was like an extra hour or two on their runtime. Like, we couldn't do that to our clients. It would be completely unusable. So the tool for the job this time was AWS's serverless solution, managed database, that was released only 2 months before we started incorporating it into our platform. Released in April in 2022, it was Aurora Serverless v2. And it's the database that was able to scale up very rapidly to support these bursts of write. And then what made it cost efficient is it was able to scale down very fast, which meant we could isolate that storage for a client. So with introducing Aurora Serverless v2, we got rid of that underutilized, very powerful shared storage. And again, another set of Windows boxes. This brings us to the end of the journey, not the end of the talk. We still have 15 minutes-ish. It was a project that took 4 years. And as I said, it finished last summer. And it did bring a lot of value to our clients. We needed to re-architect the platform, like making additional changes to the old architecture was just unsustainable. This way, we enabled developing new products for our clients, bringing them new value, onboarding more clients. And to be quite honest, we are not afraid anymore of those big whales, those investment companies that are huge. So let's go over the benefits. We have a more stable service, more stable platform, no noisy neighboring, which means also more stable file runtimes for our clients, fewer incidents. Faster platform for some of our more complex clients. Cheaper. Our maintenance costs have gone down. We don't need to do any more weekend patching, and also fewer incidents. But what is more noticeable is the AWS bill. This is the bill from April, when we were running still old architecture. The bottom 2 bars are EC2. So that was those Windows boxes that were hosting the engine and the storage. And the FSX and S3 on the top, those are the backups. Can you notice when is the weekend? Yeah, they're always on. They're always spending money. Let's compare that to September, when we turned off, when we migrated all of the clients. On the bottom, you have ECS, that's our compute. Those are those Fargate containers. S3, Relational Database Service, and DynamoDB, the top 3, that's the storage. So that's the replacement of the SQL servers, SQL cluster, but also all of the backups. We saved 70% of the cost on the storage, with doing this migration and using more appropriate storage for the data that it was storing. But that's not all. We also made it better for the environment. And that's what we are going to focus in the last part of the talk. Sustainability is talked a lot nowadays, and when we talk about it, we talk about economical, social, and environmental sustainability. Time for a confession. The environmental impact was not the main reason why we started re-architecting the platform, and how we made it greener was actually accidental at the early stages. The urgency for change came from the business risk. If you remember, it would be very expensive to support any more complex clients and to support more clients, and it would make it commercially dangerous, which was a risk for us as a business. And if we were not there, if we were not profitable, we can't make any change. We can't make a difference. However, it is very important to us, as one of the first tech B Corps in the UK, to think about the negative footprint, about the impact to the environment, and about the world we're leaving behind. The best we can do, the best anyone can do, is to not run any software. But, we are here, so we need to accept that every engine run will inevitably equal to energy costs and thus to the environmental impact. So what are we doing to reduce that negative impact? Other than being able to scale up and support bigger loads, one of our main goals was to reduce the cost and remain profitable. To reduce the cost, we have eliminated compute infrastructure waste by running the engine only when used, only when needed. This meant getting rid of those engine boxes, long-running, over-provisioned. By eliminating compute infrastructure waste, we also reduced the electricity usage. And electricity usage is usually already captured into the cost of running a service. The electricity usage is a pretty good proxy, not perfect, but pretty good proxy to the environmental impact, to the carbon footprint we are making. And in order to know if the changes we are making any impact, or even are they making positive impact, we needed to get some data, some metrics, and some numbers, and we spent some time analyzing those numbers to figure out what are the things that would bring what are the changes that bring the most value to do. And sometimes that was improving the performance, but not by adding more nodes and using more energy, but by making the rule engine be smarter instead of run harder. Most of the performance improvements that we made over time could fit into two categories. One was the rule engine that was running for a small client, for a simpler client, doesn't run exactly the same or behave exactly the same as for the more complex client. So when we onboard more complex client, we expect their runtime to go up, right? But it doesn't necessarily need to go linearly up with the complexity of the client. What we, with experience, found out that it can be much more flat. So finding those places to do the performance optimizations is gold. One of the examples, I'm a little bit embarrassed to admit this one, but there was a toString in our code that was done millions of times. The string that was just done to support a legacy feature that actually no clients were using. And it saved us so much time that if you are interested, ask me after the talk, but no, it can't be recorded on this. And then second one was what worked for a single process engine doesn't necessarily work for the distributed engine. And this is mostly to accessing the data. So we became lazy, of course. If everything is in memory, it's very easy to fetch the whole object, anytime you want it. But in this distributed world, that's very expensive. So finding those places where you're I don't need all of this data, or I can cache this data, was a solution for us. Of course, there is a secret sauce. It's the culture, it's the people, it's the part of all of this process and everything that we do. We care about what we do. We care about the environment. We talk about it. And all of this is what makes the rule engine greener. And this is how we develop the software. But where the software runs is also important. And that's the cloud provider. For us, that's the AWS. AWS is one of the largest cloud providing computing service providers. You know about it, so I'll not go in depth on that. I don't know how much they care about sustainability and environmental impact, but their clients do. So they need to care about that to be in the game, right? They will provide us, they will make it easier for us to get the data. They will provide the metrics. They'll also provide their other clients studies, case studies, to help us to learn from their examples. And they also came up with a framework to build a well-architected system that impacts environment in a better way. AWS is going to do what they can to reduce their carbon footprint. They're potentially going to offset some of it, but they do have a large carbon footprint because of the nature of their business. We do push them to get better, to be better, not only because we're good people, we are, but also because all of that carbon footprint that they have not offset, it is left for us as a business to offset. And we are also in a software industry, which means we generate carbon footprint. And it doesn't just come from running a service. It comes from traveling to visit our clients, for commuting to work, from me commuting to this conference, from having an office. And to not go into carbon offsetting too much, I'll just underline this with, we are committed to be carbon neutral by 2027, if not sooner. We didn't need to do it, and a lot of companies don't do it, but it is something that is very important to us. So we did go for it and committed to it. We're not done. We're nowhere near perfect or, being able to do everything we have done. So there are endless possibilities still. We'll keep learning. We'll get better. We'll get more data, better data. And we'll keep reducing that compute infrastructure waste. We'll be finding those performance improvement places, using the data. We'll be finding those spots and find where is that thing that we need to improve. Plus, we could be implementing parts of our solutions now with a greener way in mind. We already have the data and we already calculated the data. So we could bring more value to our clients that they're potentially getting from internal systems or from other vendors. Why do it twice? It doesn't make sense. And then we could push it further. Run some operations only when electricity grid is not overloaded. Or use the greener region or a data center. Or educate the clients to use the platform in a greener way. Let them upload the files only once a day instead of multiple times. Really, endless possibilities. And then, what can you do? Of course, get the data. Make your decisions informed. It's also very rewarding to see the impact that you have made based on your data. Talk about it. We as a community are much more powerful than as individuals. So we need to talk about it. We need to learn about it. We will get it wrong. It's just, I wouldn't say in our nature, but we need to experiment to find out what works, what makes the impact. There is no such thing as a perfect solution. So let's just not get paralyzed by that. And we need to take the risk that we actually might get it wrong. And let's make it easier for others to start working on this, to start thinking about this. Let's make it easier and faster to test something, to fail, and then to try the other thing. But you know what? It's not okay. Our planet is screwed. Every other company out there is a software company. 20 to 25% of electricity usage is attributed to digital sector. This might blow your mind, but this is above aviation. And I'm sorry to be the one to tell you, but that's us. As software engineers, we have a big role to play. And we are right at the beginning-ish, so we should switch a gear. This might be a decision of our time. Do you really want to be the one who is speeding it up to make this worse? And then if you don't care about the planet, the environment, people living on that planet, or like planet is going to be fine, like us living on the planet are not going to be fine. Think about this. Your next employer, your current employer, or government will ask you to have that skill to write a low consumption, low usage code. It's not going to be an option. And this skill might land your next job, or actually not land it because you're not going to have it. So get better at it. And I'm going to leave you with one more that really stuck with me that my CEO said. Every dollar you choose to spend is a vote for the future you want to live in. Choose it wisely. Thank you.